We are currently in the middle of a solar cycle that could bring us a magnetic solar storm on the scale of the Carrington event of 1859. What are the true risks to our civilization, and when will the megastorm hit us inside the storm? The sun is going crazy, and scientists are wondering what this will mean for us. If the sun's magnetic field flips, we could have a serious problem on Earth. Massive convection currents generate a force field that ensures masses of extremely hot solar material are continuously heated up. This is how the magnetic field, also known as the sun's force field, is created, and we are so reliant on it that it determines which particle currents hit us and how strongly. We call these currents solar winds, and they shape our climate. The sun's plasma currents are beneficial to us because they warm our planet, allowing for vegetation and life, and the sun's light illuminates our planet. But they can also be detrimental. Since then, a lot has changed. Today, we are a civilization. That depends on electricity, and we can imagine what a solar storm could do to our planet. Imagine how your refrigerators and coffee makers would stop working in the morning. The sky would be a sea of colorful lights, all communication media would be down, and no one would know what had actually happened. In the 19th century, a massive solar storm paralyzed the then very young power supply for days on end. To understand the true threat, we must go back to the beginning of the sun. Imagine a time 4.5 billion years ago, when our sun was born in a cloud of gas and dust. Given these facts, do you ever wonder how a gigantic and blazing hot ball of fire could have been created simply from dust and gas? That's why scientists are keeping a close eye on the sun, and things have appeared here in recent days and weeks that don't seem quite normal. The biggest concern is the sun's magnetic field, which could be about to flip or even undergo a massive collapse that could endanger us all. The fundamentals of fusion processes at the atomic level are the same processes of induction and deduction that we still find on the surface of the sun today, and in its interior, the bubbling in the deep layers of the sun creates convection and plasma currents that are pushed upwards. This question remains one of the great mysteries of science, and we currently know so much that this collection of dust and gas was set in motion at some point due to processes that have not yet been explored. At some point, the movement became so fast that the internal pressure became so great that the hydrogen and helium atoms fused, producing incredible amounts of heat, and the sun began to glow like a giant power plant. The sun's internal electrical and magnetic processes generate the solar magnetic field. In addition to gases like hydrogen and helium, the sun is made up of many other elements and metals that interact intricately. All things considered, the fireball that is visible in the sky every day as a yellow disk is a highly intricate marvel of chemical and physical processes that are so flawlessly coordinated that we can only marvel at them. However, how does it fit into the picture that our life-giving fireballs can also pose a serious risk to us? The biggest threat comes from sudden and unforeseen events on the sun's surface. The magnetic field is very dynamic and changes periodically. Due to the immense turbulence and dynamics, the solar magnetic field is different from the Earth's magnetic field, and we humans closely monitor these changes because they are related to the sun's plasma ejections, which can bombard our planet with streams of particles. Normally, even the most violent solar storms would hardly harm our planet because it knows how to defend itself, and the particle bombardments only damage our electrical systems. Since we are completely reliant on satellites and communication networks in the 21st century, in certain situations our lives depend on them, they are vulnerable to disruption. If the power and navigation systems unexpectedly fail, hospitals would be in a difficult situation. Additionally, aircraft in the air could lose their bearings and have to land in dark airport facilities at night. Does it really help if we understand solar cycles? Did you know that we are currently in a solar cycle that could bring us an event similar to the solar storm of 1859? The Carrington event went down in world history. ATMs, cold chains, and supermarkets could fail, and ultimately the biggest risk is that mass panic could break out among people if the sky is on fire and the familiar environment no longer functions. Telegraph stations, which at the time were the pinnacle of technology and akin to modern phones and smartphones, failed all throughout the United States and the world. People from all around the world were able to coordinate and communicate for the first time. Of course, these communication networks were still sluggish by today's standards, so it took a while before the true nature of the situation was recognized. Back then, a massive solar eruption threw plasma in our direction, and our magnetic field caught the plasma. Normally, the Earth's magnetic field shields us from excessive radiation from the sun by collecting particles, binding them, and allowing their charge to run dead. However, if the particle density is as high as it was in 1859, the protection does not function properly, and more particles penetrate into the deep areas of the Earth's atmosphere. This occurs more frequently at the poles, and we all know and love the effect in the form of the magnificent auroras and polar lights. In 1859, this is exactly what happened. The magnetic field was insufficient to shield us, allowing large amounts of charged particles into the deep layers of the Earth's atmosphere. Sparks flew from the sparse electrical systems of the time and caused fires. At times, people believed it was God's retaliation or the final punishment, but only the researcher Richard Carrington realized the truth. Other electrical systems operated just on the energy in the air and sent nonsense all over the world as if by magic. The science of studying solar activity and solar cycles developed from Carrington's insight. We are currently in an 11-year cycle that will reach its peak in 2025, but something is wrong with the sun. It is behaving strangely. Here comes the fatal part. Scientists feel safe because they thought they knew the sun and its activities quite well and could make reliable predictions, but the sun shows our researchers that it is not as predictable as they had long assumed if we take a closer look. Several days later, relief set in, and after 2 weeks the entire scare was over today. Research into solar activity has only been providing us with reliable results for a few years. The rest of the predictions are based on computer simulations and old observation data obtained with fairly simple telescopes. Scientists use this data to create a solar calendar and their predictions. However, we are currently seeing that these do not always have to be correct, and there may be much worse to come. Worrying change in the sun's magnetic field in the spring of 2024. An unusual spot appeared on the sun that brought us such violent solar storms in the first half of the year that researchers are baffled the auroras generated by the storms were visible in the USA, Southern Europe, and even in Hawaii and Australia. Although the power outages were only regional, even Elon Musk was shaking for his brand new Starlink satellites at times. If this was just the beginning, what will the peak of this solar period bring us, or was this already the peak? And our scientists were wrong again when they predicted the most violent storms for the year 2025. In recent years, the sun has been so unpredictable that we have to expect big surprises. In practice, we have to realize that a storm that paralyzes everything can theoretically hit us at any time. If we remain realistic, we have to face the unpleasant truth that the sun has often shown activity that does not fit into previously known. Researchers here assure us that the jumps in the sun's magnetic field are actually quite normal, arguing that the changes in the sun's magnetic field could very well lead to even more violent upheavals and eruptions. However, they still do not see an all-destroying monster storm coming, and they are still certain that major solar eruptions will be announced by sunspots or detected in good time by our solar observatories. In 2003, the flare that caused the violent Halloween storms was detected just a few minutes before it arrived. In some cases, particle streams from the sun can sometimes take only 20 minutes to reach us, and larger ejections and clouds can sometimes travel for 2 days before they hit our magnetic field. Whether this confidence is real, or if we shall be caught off guard one day, will only become clear with time. Subscribe today to be included in all next videos.